Good afternoon. It is Thursday, September the 7th, about 3:40 p.m. This is Shay Gibson with WeatherFlow bringing you a Tropics update as we continue to monitor a very active tropical Atlantic basin. We have three hurricanes out there. We have Hurricane Katia in the southern Gulf of Mexico nearing the Bay of Campeche. We also have Hurricane Irma, which we're watching very closely, that is looking to have impacts on the United States. We also have Hurricane Jose out here in the main development region. So all three systems, all three areas of the Atlantic basin are active right now. The peak of the hurricane season is September the 10th, so this is not abnormal to see a spike in activity, but impressive nonetheless to see all three zones active. Let's go ahead and take a look at the map, hurricane map. This is the 2 p.m. update, NHC update. Katia with winds of 80 miles per hour, pressure at 980 millibars. Movement is nearly stationary. If we look at the track of the system, it does take it to the southwest over time. Hurricane warnings are up for portions of eastern Mexico. The main concerns here will be heavy rain and mudslides and flooding for that area, which can be deadly at times. If we take a look at Katia on the rainbow imagery, we see more of a blowup of convection. It's not the most organized hurricane that I've ever seen, but there are hurricane force winds involved with this, so it's a major concern for eastern Mexico in those mountainous zones and dry kind of desert or arid climate where we could see a lot of those mudslides occur. Going back to the map, let's take a quick look at Jose. Out here to the east-southeast, winds of 105 miles per hour, pressure at 978 millibars. Movement is west-northwest at 18 miles per hour. This track takes it on an eerily similar track of Irma, except turns it to the northwest in time. The steering patterns are a little bit different. I wouldn't be surprised to see a little bit more of a westerly track. It might include some of the Bahamas in time, but for right now, we're going to follow the NHC guidance on this. It is anticipated to become a major hurricane as we move into tonight and to tomorrow, which is very concerning because the northern leeward's already under hurricane watch again after getting dealt a serious blow by Hurricane Irma, and they just got hit by the largest or the strongest storm on record for their islands, and now they're back on the table again with hurricane watches to be hit by a major hurricane. So I'm a little suspicious about it becoming a major hurricane status because Irma, with winds of 185 miles per hour in that area as it neared those islands, may have churned up the sea surface, not sea surface temperature, turned up the water to cool the sea surface temperatures several degrees. So if we go back to the water vapor imagery map, activate sea surface temperatures, we see in that area where the northern leewards are that the sea surface temperatures readout is 29 degrees Celsius. I bet that that's more about 27 to 28 after Irma has gone through there, maybe even a little bit cooler than that. So Jose has a little bit of dry air ahead of it, maybe some cooler sea surface temperatures. Maybe we'll see the system not make it to hurricane or major status and spare those islands a little bit of grief because they just went through a huge ordeal. Here's the rainbow imagery for Jose. We can see that it's starting to develop a well-pronounced eye, a little bit of shear from southwest to northeast across the system, which is keeping it on the weaker side for right now. Whoop, let me darken that marker up. There we go. From southwest to northeast. So we're seeing those cloud tops being kind of pulled off here as it moves into this general vicinity. The upper shear sort of relaxes. We see sort of a north to south shear, but that upper zone is going to be moving away. This is in wake of Irma. So the outflow from Irma, it's all funneling back down into the monsoonal trough and back up into the system. There's plenty of moisture there below that dry air. In fact, if we take the sea surface temperature off here, take a quick peek, we can see that there's still moisture abundant down below. We also have a little bit of moisture down on this area. So we have a little bit of a monsoonal trough down this way. It's all feeding into the system. Plenty of moisture for it. You know, the track of this thing heading towards the northern leewards is just really unfortunate. So we'll continue to watch that one. Let's go ahead and take a look at Irma. Irma has winds of 175 miles per hour, down 10 miles per hour from last night. Pressure is at 922 millibars. Movement is to the west northwest at 16 miles per hour. We take the track for it right through the uprights between the Bahamas and Cuba. Hurricane warnings are up for all of the Bahamas, and we're seeing tropical storm warnings for Cuba. The system does look like it's going to have some land interaction, which drops it down to a Category 4. We think that we're seeing that already. In fact, if we take a look at, see if I can pull this up here, bring this into the picture. This is the morphed integrated microwave imagery of the core of Irma, and we can see that the outer eye wall, there's two eye walls, an outer and an inner. We see the outer eye wall is breaking down a good bit. It's got some dry air fluxing into it. It looks like it may be going through a replacement cycle. The inner eye wall is also breaking down, so we may see a complete eye wall replacement cycle, or ERC, for this system ongoing as it goes to the north, continues north of Hispaniola. But we have more mountains coming up in Cuba which is also a further mechanism to sort of keep the core a little bit on the weaker side. So we may see the system drop to a Category 4 status. In fact, we look at our wind alert storm tracker. You can see this free. This is a great tool to use. It has all of our weather stations in it. www.windalert.com/storm/Irma. We see that the category status drops from a 5 to a 4 as it approaches just north of Cuba. And then as it goes ashore into southern Florida, it will be a Category 4. That is the thinking right now. That's a pretty fairly certain outcome at this point. Very unfortunate because Miami's right in the middle. Now notice that this cone of probability here is very wide, so we still have some wiggle room for the storm to stay off the coast, or it could push west along the western side of Florida. We can't rule out any of these options yet. This black line down the middle just represents the center of the track, but does not necessarily represent the actual path of the storm. If we go closer in, we see that a Category 3 is forecast to remain here with this scenario by Monday, September the 11th at 8 o'clock a.m. This is 96 hours from now, as a Category 3 with winds of 120 miles per hour heading towards the South Carolina-Georgia border. So if you live in any of these areas within this track, you should have a hurricane plan ready, because even if this goes ashore over Florida, it could still remain a very strong hurricane all the way up and into the Carolinas. We're going to get into some more detail, but this area is all susceptible to some very nasty weather ahead, some very bad conditions. We have a northeast wind diving down from the north, and we'll get into that as well. That's going to be maybe a weakening factor for this system. Let's go ahead and take a look. Hurricane Recon is in right now. They're finding pressure of 922 millibars, not too far from what we're seeing now. So the 5 o'clock update may keep things almost the same. The track may shift a little bit. We'll get into the modeling here in just a second. Wave heights for buoys. Northeast Bahamas buoy, swell heights out in this area. This is a little bit further away from the storm. We're seeing only maybe 8 to 10 feet. Some of the closer areas, this is to the northeast, East Bahamas buoys, or East Bahamas buoy, got up to about 22 feet, and it's back down to about 19 feet at this point. We have more buoy information ahead. Some of these are just island stations, so they don't have any water level heights or anything like that. But as we get closer to the southeast region, we have some more National Data Buoy Center buoys out here that will give us some valuable information on wave heights. I know there's some questions about wave heights and surge, and we'll get to that as well. Let's take a quick look at the GFS modeling. This is the 850 millibar chart. Not quite at the surface, a little bit higher up. We have a major feature here, which is keeping that system to the west, going to the west-northwest. We can see the edge of it here heading in this direction. This is what is keeping that system suppressed down to the south. In time, this ridge will back away. You can see it nosing all the way out to here, which is going to drive the system towards southern Florida. We'll see that back away. This is called a ridge axis right here. As that axis breaks down, the extension of the center backs away, and then we see that we get that northerly turn in time. There's another reason for that northerly turn, and we'll get in that in just a minute. But look at this track for the GFS, brings it just along the eastern side of Florida and up into the South Carolina-Georgia border and inland. So this system, even the Euro is agreeing with this, where this is an inland penetrating system. And even if it comes straight up Florida, it's still an inland penetrating system, which means driving rains, tropical storm force winds all the way up into the mountains. It looks like this is going to be a really nasty situation. Lots of rain involved. In fact, we look at the rain chart for the next 5 days. We have a foot of rain estimated for along the coastal zones, with this wraparound Atlantic and Gulf Stream flow coming around the system into the coast. If it takes a center track in Florida, I'm sure that these darker colors or these warmer colors will extend further off to the west and include all of the state of Florida. We see the rainfall amounts near the Bahamas 27.8 inches. That is impressive. These numbers may be lowballed. We may see these numbers come up in time. In fact, we may see 14, 15 inches develop here. We may see these numbers come up as well. In fact, I think we have 6 inches estimated for western North Carolina. That could come up to 8. We could see 14 inches here at the coast. So these numbers are not set in stone, and as the system tracks north, we'll have a better idea. Let's go ahead and take a look at the Euro model. Euro, very similar. They've been in a lot of agreement for the last day, and now the Euro is starting to shift the storm a little bit further west over the southern tip of Florida. So here we are right here with the Euro. The GFS, remember, just a little bit to the east. Now the Euro is pushing it straight up Florida and more along the western, I wouldn't say the central, but kind of the western side of Florida. That's where the cone of probability comes in, because we're just not entirely sure once it makes that lateral move from east to west, and then once it starts to do that y-axis north shift, then we'll know, we'll have a better idea of which direction the storm is actually going to take. So it's still up in the air as to whether or not we're going to have another landfall, maybe two landfalls, one swiping Florida and coming up and hitting landfall again along the Carolina coast from here offshore and then into here, or are we just going to have a solid landfall right into Miami and go straight up Florida right into the heart of the southeast? Either way, we have a warm body here, we have a warm body of water here, we have moisture feed coming in from the Gulf, moisture feed coming in from the Atlantic, so that's going to keep the rain shield and the core of the system warm. It's going to keep this system strong all the way up. So even if it hits as a 4 here, we could still be looking at a 3 here, or even a, it may back down to a 2 by this point, but we're still looking at a fairly strong hurricane even as it heads up into northern Florida and into Georgia with this particular scenario. So we look at some of the reasons why this northerly turn is going to happen, and we start looking at some of the upper dynamics. Let me go back to the height here. This is 500 millibars, just a little bit higher up. Right now we have an upper trough that is associated with kind of an upper low. This upper trough is digging across and down into the southeast United States. Now this is going to move off to the east and to the northeast. It's going to kind of go in this direction. Down here we're going to see an upper low develop, and it's subtle, but it's just subtle enough to bring that storm kind of in this direction. So wherever it is, there's going to be kind of a swing in the atmosphere, and you see this Atlantic ridge right here that is still building in, but eventually in time we're going to see a pull into the coast. And if we run this model forward in time, we see a ridge building to the north. So we have high pressure here, capping. This is actually a blocking feature, and this is going to be driving down a northeast wind all the way down the coastline. This is good cooler air. So this actually, I'll make a quick point here, that this could be a cooling mechanism for the storm. You have cool northeast air driving down into the system that could actually help to weaken it a little bit quicker. We're going to get into some of the sea surface temperature talk here in just a minute, but we'll run this one forward and we see how it just runs right into the southeast region. There's some other components here. Let's look at the upper dynamics in the GFS. Let that run, and we can kind of get a good idea. We see Irma down here. This is about 36,000 feet, so we can see that the low pressure is very high up into the atmosphere. It goes from mid-level down to surface, but we're also seeing upper, and then we usually have a high pressure on top of that. But either way, we see an upper low sort of branch off from that trough right here, and this is going to create sort of a pulling mechanism at these levels up, and you can see how the jet kind of goes up and over. But this is all going to be sort of pulling the system into the coastline along with that high pressure driving down into it. So we have a pinch play going on. We have a high to the north with this direction. We have this upper low here with this direction. The storm really has nowhere to go. So the window for this system to be able to head out to sea is closing very quickly as time goes on. We can even see this in the European model. This is the ensemble run with 51 members. And it starts out as a singular point from the initialization period, but as we go into time, we see each individual member doing its own algorithm, and you can see what it's doing. So you see these individual circles start to branch off. Those are individual solutions as to where it's going to go. Now watch that. All 51 members of the Euro all pretty much keep it right into Florida, right into the southeast region. There's maybe one outlier out here that keeps this thing off the coast, but all the other ones basically bring it into the southeast region. It's becoming more and more of a certainty at this point. It's just to what degree everybody's going to feel this system as it heads up. Let's go ahead and take a look at the NAM. This is another model. This is a higher resolution model. We're starting to get to where we're seeing these models pop in now because they only go out a certain amount of time, and then they only generate for 84 hours. So this is the NAM 12, which is a little bit higher of a resolution. As we go further into time, we'll get the NAM 3 kilometer in, but we can see this system, this model brings the system in very similar to the GFS, but it's also starting to sort of look like the Euro at this point with a further westerly jog, but then it does bring it off the coastline. We can't go any further than that with this model, but it does show a similar track to the Euro versus the slightly easterly jog from the GFS. So we're fairly certain that South Florida at this point, I think it's an imminent situation. If you live anywhere in this track, you need to have your emergency plan activated. This is a serious situation starting to develop. Hurricane watches are up for Miami, the Keys, portions of southern Florida, even up towards Orlando. We're going to see these hurricane watches and warnings start to extend further north as time goes on. The rainfall amounts are enough to tell you to get away from the coast. This is a major flooding situation, not only that with the storm surge. Now storm surge becomes another question because of where the system is going to be coming from, where it is and where it's going to be coming from. It's a tricky topic. So we're looking at the I'm looking at Datascope right now, and the reason is because I want to zoom in. Let me turn the satellite off. I want to look at some of the bathymetry via Google Earth. This is pretty good. When you get a major hurricane in this area, we have a lot of shallow water, so the surge may not be as high. The wave heights can't get too much higher than a certain point where the waters are shallow. So you may see 20 feet versus 40 feet out here in the deeper water. So it's going to be very tricky to see what the wave situation. Storm surge, though, we can look at the hurricane NHC, any area that's activated under a watch or warning. These inundation maps are fairly new, they're experimental, but you can start to see these in the NHC site. And this is going to give you an idea of what your surge is going to be. For right now, they're calling for greater than 6 feet above ground, and a lot of portions, even Homestead, all the way down to around up towards Miami, we're only seeing greater than 1 foot. I'm sure these numbers will start to climb. You're seeing some areas that's greater than 3 feet and 6 feet start to populate. It's a high-resolution model, so it's a really good one to use, and it goes all the way up to a certain point where the watch zone ends. But as time goes on, these maps will activate more and more up the coastline, so you can have a better idea. I don't think the western side of Florida is going to be at risk for surge because of the offshore flow from the hurricane. It actually might be driving some of the water out of Tampa Bay. I know that some Tampa Bay folks were especially concerned about it flooding in their area. Well, when you have offshore winds wrapping around a storm like this, you tend to get water moving out versus in. The eastern side of Florida, this is more susceptible to getting more of a surge into this area. Florida is a little bit more flatter, but as we head north up into the Carolinas, with a system that's kind of incoming off the eastern side and into this area right here, again we have this wrap-in flow that could increase the surge in this area. So again, we have bathymetry to consider because this is the Florida Hatteras Slope, and all along here is the coastal Carolina shelf waters, which are relatively shallow. So if you have a system following up the coastal shelf over relatively shallow waters, it can only generate a high swell short period fetch, and so that keeps the swell heights down a bit. So instead of, like with Hugo, always use Hugo as an example because this was coming in from the southeast to the northwest, and that drove all of this deeper water swell, this high swell long period fetch right into the coastline. I mean, it was a straight beeline, and it just pushed all that water right into the coast. And so that's why we had a major surge here in Charleston during that event. But when we got one that's coming up from the south, as we saw with Matthew, I think our surge was only about 4 to 6 feet. But with the Category 3, we can add to that. We take a look at the Saffir-Simpson Scale. Here's Category 3 at 9 to 12 feet. Category 4 for southern Florida, 13 to 18 feet. That may not actually be the case when it comes down to it, but with the rainfall and the driving waters into the coast, we could see something near 13 feet. It's hard to say right now because of the shallow waters in that area, and the surge tends to go a little bit further inland. So back to the Carolinas, you tend to find the surges a little bit more inland as well. So where the beaches on a Category 3 could get high wave action and some water movement, a lot of times the estuaries and the watershed and all these areas inland tend to get the higher flood because that water is pushing in all the way into the coastal breaks. And if we zoom in here, we can see some of these coastal breaks here. You get driving force like up Harbor River, for instance, or even like at Edisto, at Hunting Island, these areas, these coastal breaks where water just sort of pushes in into the marshlands, and you end up getting a lot of flooding in these zones inland because of that. And then on top of it all, when you have a system that's pushing up from this, into this area, and you have heavy rainfall amounts going on, you have river swelling. So then you have water trying to escape this way, you have water trying to go up this way, and you're not left with nothing but a giant bowl of water over these areas. So it's a bad situation. If you live in a flood zone or a flood prone area, you definitely need to be considering this. And once again, looking at this track, anybody in this zone here needs to be preparing for a hurricane and activating your plan now. Wave heights, very, very difficult to pin down. I'm going to run the Wave Watch 3 model, and we can take a look. This goes out to 180 hours, but I'll stop it at certain points. As it goes through the Bahamas, you can see the swell heights are down even at a Category 4 because of the shallowness of the waters. But as it emerges from South Florida, we see the swell heights start to build even along the shallower shelf waters. We see the swell heights start to build to the north ahead of the system if it continues to be on that track. So we're looking at higher wave heights as we get up towards South Carolina and North Carolina for a period there. It's very difficult to pin down. We'll have to keep watching to see which track this takes. If it goes over Florida, we'll have less of a surge. Along the eastern side, we'll have less of a wave height. But we'll continue to watch. Again, here's the rainfall amounts. Take this very seriously. All these areas, we've already had a lot of rain from that recent cold front. We've had a lot of rain in the last 30 days, so there's a lot of standing water already. And now we have another foot of rain penetrating inland to the western Carolinas. We could see, upwards of 12, 14 inches push all the way in to maybe 6 to 8 inches all the way to western Carolinas up into the mountains. So that's going to do it for this tropical update. I hope I was able to answer a lot of questions there. Just a lot of material to go over when you get into a system like this that's coming from basically south to north. And we'll have to basically wait and watch and see what happens. But again, I'm going to show this track one more time because these are the areas, if you live in this, within this cone of probability, it doesn't matter where you are, you're going to see some bad situations. You're going to see some really nasty weather coming your way in the next 3 to 4 days, or 5 days in some cases, up through Tuesday to the western Carolinas. So they even have a tropical storm here at this point, even as it penetrates inland. So keep that in mind. I'm going to go ahead and end the tropical forecast with that. And everyone have a good day. Thanks. Take care. And I'll be back hopefully on tonight on my Weatherflow page, Shay Gibson-Weatherflow on Facebook. I'll try to do a live feed sometime, hopefully around 9. Don't hold me to that. I've got a plan for evacuation myself. But either way, everyone take care, have a plan, and I'll see you soon.